So today's video, we're going to look at the third way of charging a neutral object. And this is called charging by induction. So this is straight out of the notes in your package. I'm not going through a PowerPoint in this because I find it's easier if we just go through the diagrams ourselves. So here's what happens during an induction when you're charging by induction. So what happens here? Here we have a negative charge in the ball, okay? Then I have this rectangular rod that's neutral, okay? So to start off, what's happening? Nothing's really going on in this case. They're both just hanging around. But what we're going to do, we're going to start to bring this closer to the metal bar, okay? So when we get to the second step, the negative charge is close to but not touching this metal bar. So when you draw in, remember your positive charges can't move, so we sort of have to draw them in the exact same spot where they were before. But now what's going to happen, because the positive charge is going close, all these electrons are going to want to move away. So they're going to shift towards the end of the bar. So we're going to draw them all the way over here. Okay, so if you want to write what happens, the electrons flee to end of the bar. All right. Now the thing with charging by induction is that this negative ball will never actually touch the metal bar. That's the new part here. So I'm just going to scroll down and hope that this works for me nice and well. So now we're on to the third step, okay? What happens in the third step, again, we still have our positive charges that don't move. Okay. Now what happens is that ball stays close to the bar but never touches. And now what we're going to do is we're going to create a ground. So this is the symbol for a ground. Okay. And actually, you know what? I'm just going to erase that. I'm going to do it in a different color. So I'm going to do it in red. So this is a symbol for a ground. So basically, how you ground something, you can touch it or you can put another metal to it. So what is happening here? A bridge to the ground will appear, and it allows electrons to leave, because now these electrons are trying to get away from that ball, that circular negative charge. So if they can actually escape the metal bar, they will. So this is what's going to happen here, is that all the electrons here that moved to the end of the bar are actually going to now get out of here. Okay. So then what happens? Well, then in your next step, again, you still have your positive charges that don't move, okay? And the bridge breaks, okay? So the bridge breaks, and now you can't allow any more electrons to escape. So the bridge breaks, okay? And let's say most of the electrons left, but we still have 2 remaining electrons in this example. So those 2 remaining electrons have to stay at the end of the bar, again, because they're trying to stay away from that circular negatively charged ball. From the ball. All right, and then in the last step, what we have, oh, my drawings got a little bit messed up here, but that's okay. The last step, again, we still have those positive charges that don't move, and we've got 2 electrons. Okay, but now what happens is this ball goes away, and I'm left with, overall, a positive charge. So the key with charging by induction, oops, I don't know what just happened there. No, I don't want to do that. Sure. Okay. So the key, what happens with induction is when you have a negative charge to start off with, you're going to end up with the opposite charge in your metal bar. So in this case, I started with a negative charge, and my metal bar ended up with a positive charge, okay? But the whole thing is there was no contact here. This isn't charging by contact, so that ball never touched my metal bar. Okay, so the charge happened by induction. It got close to, but it never actually touched. Oh dear, no, I do not want to save those changes. Oh dear. Okay, well, that's the end of the video anyways. So if you have any questions, we'll clear up any questions you have in class.